Bet šobrīd atļaušos pārslēgties uz angļu valodu, jo mums ir arī programmā viesis no ārzemēm. Ladies and gentlemen, switching to English, our next speaker is coming to us from abroad. And actually, Latvia just recently has achieved a significant milestone when it comes to this industry. It has gone through audits, gone through a lot of homework, and it is now a part of the International Energy Agency, which of course provides us new opportunities, new analysis, new data, and also new experts that can come and help give us an outlook on things that are happening right here in Latvia. So, ladies and gentlemen, please help me welcome on the stage. He's the electricity analyst of the International Energy Agency. Ladies and gentlemen, Mr. Eren Çam. Let's welcome him on the stage. Eren, happy to see you.
Thank you very much.
The stage is yours.
Very pleased to be here. So, yes, if I can, yeah. So perfect. Yeah, thank you very much. Again, I'm very pleased and honored to be here. My name is Eren Çam. I'm an energy analyst at the International Energy Agency based in Paris. And I'm also working as the project manager of our electricity market report series. So today I'd like to present you an overview of our recent electricity demand and supply trends with a particular focus on the role of grids in secure energy transitions. And the analysis I'll be presenting you today are based on our recent publications. So one of them is the Electricity Grids and Secure Energy Transitions publication, which was launched end of 2023. And the other report is our Electricity Market Report series, which is an annual recurring publication, which we just published early this year. So with that, maybe let's take a look at the European electricity demand trends first. We have observed in 2022 a 3% decline in electricity demand in the European Union, and this was followed by another 3% decline in 2023. With these two consecutive declines, we now have come back to the electricity consumption level in the EU, which we last saw 2 decades ago. So this is quite significant. And the majority of the decline occurred due to the output reduction in the industries. I mean, the major reason was, of course, the elevated energy costs following the energy crisis, but also, especially in the year of 2023, the slowing down in the overall macroeconomic environment was a significant factor. Now, when we look at the industries, especially the energy-intensive industries, we see that chemicals, but also primary metal production, so such as steel and aluminium, these sectors have already shown signs of permanent electricity demand destruction, and we expect these sectors again to remain vulnerable to energy shocks also in the upcoming years. Nevertheless, as the energy prices are now moderating, and we expect them, assuming that it continues like this, we expect some demand recovery in the industries over the next 3 years. And the demand recovery, or the additional demand we will be seeing in the European Union, so half of it is coming from the industries as they gradually recover, but also the other half, which is quite, I think, significant to mention, is coming from new electricity demand sources. So let's say unconventional sources such as the electric vehicles, heat pumps, and also data centers. So out to 2030 and beyond, we also expect the electrification in the industries to continue and gain pace. And on top of it, also hydrogen production from electrolyzers will come and be a significant driver of electricity demand growth further. But as you can see in our analysis, the electricity demand comes back to 2021 level, I mean, at the earliest in 2026, and from that onward, we expect significant growth to occur. So another important trend is, of course, the increasing rate of self-consumption, not only in Europe, but also in many other regions globally, we are seeing as distributed generation, especially from solar PV, gains pace and increases, we are seeing more and more self-consumption happening. And currently, according to our estimates, in countries such as Germany and Spain, we are already seeing about 1%, so self-consumption amounting to about 1% of total electricity demand. And in Italy, for example, this is almost 2%. So what does this mean? This means that, I mean, you can see the trend, it's increasing, and as the distributed solar PV systems become more and more common, we will see this also increase, the self-consumption rate. And the importance of this is that the data of self-consumption and how it is estimated will be much more important, because in order to understand the historical demand trends, first of all, we need good data, but also in order to make better projections, again, this will be very important. So how this data is collected, estimated, and also communicate to the national statistics will be very important. So we have seen that the demand side is changing rapidly, but also on the supply side, we are seeing very fast-paced structural changes. On a global scale, if you look, solar, PV, and wind, their share in total generation was only single-digit percentage points, I mean, a decade ago. And now we are already seeing 10% share in global generation. And if you look at the European Union, this is even higher at 20% of the generation. So the trend is clear, and we are expecting this to continue in a strong pace, especially if the countries are able to achieve their national climate pledges in a timely manner. Then this would mean that all the additional capacity added out to 2030, I mean, of this, 80% of this would be solar PV and wind. And for comparison, this is roughly double the rate or double the share we have seen over the last 2 decades. Again, this shows you the extent of the growth which is expected to happen. And of course, we have seen the developments on the demand side and now on the supply side. The important thing here is that the grids, of course, develop at the same time, because we are facing the risk of grids becoming a bottleneck for the energy transition unless they also develop in a similar pace as we are seeing in the renewable side. And unfortunately, grids are already becoming a bottleneck for energy transitions. This is especially clear when we look at the connection queues of renewable capacities. And these are almost exclusively solar, PV, and wind. And we are currently seeing about 1,500 gigawatt of capacities in advanced stages. So these are projects in advanced stages, and they are waiting to be connected globally. So this is quite a big number. And if you compare this, so this is 5 times the amount of renewables that was connected or installed in 2022. So the extent of this delay is very clear. So the key reason of this delay, so why are the renewables not being connected in time, on time? So one aspect is, of course, the administrative hurdles, the permitting procedures, they are taking time. And here we are seeing some momentum, of course, to reduce these times. But also a big component is, as I mentioned, that while the investment pace in the renewables has been rapidly increasing, the grid side has been mostly stagnant. And this is very clear, and we expect more attention to come to the grid side as well. Another thing I'd like to focus here is that, again, the issue of data availability and data transparency, because we are now, in this analysis, we collected data from the relevant stakeholders, from relevant platforms, but this only amounts to about half of the global total capacity. So in reality, actually, the connection queues are probably much higher than this. So again, I would like to emphasize the importance of data availability and data transparency, because these will allow us to better understand what is going on and also help us propose suggestions to fix the problems. So we have talked about the investments on the grid side, what's happening. And over the last 2 decades, when we look at the global numbers, we see about 25 million kilometers of grids having been built. But this has to, according to our projections, this has to more than double out to 2040. So on top of the new builds, again, 30 million kilometers of grids need to be replaced as well because of aging infrastructure. And when you look at the total numbers, you'll see 80 million kilometers of grids need to be built from scratch or replaced over the next 2 decades. And this 80 million kilometers is equal to the amount of grids, the distance, the kilometers we have today globally. So in 2 decades, we need to build as much as grids as we have now, which we have built, over let's say 100 years. So this is, I think very important to see the scale of things. And from an interesting maybe perspective, 80 million kilometers is such a distance that you can wrap the Earth more than 2,000 times with such a distance, right? On the investment side of things, the annual investment grids have received in 2022 was $300 billion globally, and this has to ramp up to $600 billion by 2030 in order to align with the pace we are seeing on the renewables as well. The issue is, if we continue to do things as business as usual, if the investment occurs at the recent growth rate, then, of course, we see a gap forming, and this investment gap will be very crucial to fill. And, of course, following this, we have asked ourselves, what happens if the grid is delayed? The grids are not built on time, and then we have calculated an additional case on top of our base case, and this is the grid delay case. The issue in this case is, of course, the renewables are not integrated on time, so they also, as I mentioned, every unit of capacity you need to integrate becomes harder and harder when the grids are lagging behind. So in this scenario, you will see about 15 percentage points less share of solar PV and wind in total generation by 2050. So this is very significant. And this also has an implication on the need for more fossil-fired generation. So, for example, when the grids are not there, this would mean that the coal-fired generation decline we would have is basically cut in half. And the natural gas-fired generation actually increases instead of declining. So what this means economically, especially for countries which are importing fossil fuels for their power sector, this means about $500 billion of additional costs over this time period from 2020 to 2050 that they pay, basically. And this has, of course, implications on the CO2 emissions of the power sector. So the decline we would be seeing normally is now much less pronounced. So CO2 emissions globally also fall in a, let's say, a lower pace. So this is, again, very crucial also on a climate perspective, jeopardizing the climate goals globally. Another aspect I'd like to emphasize, of course, when, or in the case, if the grids become a bottleneck for the energy system, then we risk also higher likelihoods of power outages, I think this is very clear. The issue is power outages are very costly to our economies, to our society. I mean, in addition to the economic costs, there are also human society costs as well, of course. And our estimates show that globally, I mean, now, for example, each year we are having $100 billion of costs globally, and economic costs, due to power outages. So again, this shows the extent of the importance that the grids play in our modern societies. So wrapping up, I'd like to emphasize the aspects of demand side changing rapidly, again with new unconventional sources of electricity demand coming into play. On the other hand, simultaneously we are seeing a rapid structural shift in the generation with variable renewables increasing their share substantially. And so these two components, of course, means that they need to be integrated and connected with reliable and strong grids. So if the grids are lagging behind, we will eventually have problems. Today, I hope the discussions here will also be very fruitful to understand the challenges better and address them in a timely manner. So thank you very much.